Good afternoon, everyone. I welcome all of you to the second day of our online faculty development program on artificial intelligence, machine learning, data science for engineering application, jointly organized by E&ICT Academy and Department of CSE NIT Warangal in association with Department of EC SJB Institute of Technology, Bengaluru. So, in today's schedule, we have two sessions. First, we'll discuss about the supervised learning. Under supervised learning, we have regression technique and classification. So, in the first session, we are going to discuss about regression technique. Especially, we are going to see four different type of regression techniques and their implementation using R programming. And in the second session, we'll see one of the very important uh, algorithm, one very famous and well-known algorithm that is called as nearest neighbor algorithm, or we call it K nearest neighbor algorithm. So we'll see the nearest neighbor algorithm, K nearest neighbor algorithm, and its several variants, so that you will know what are the differences in their variants and which one is more appropriate for a particular application. So this is in today's schedule. So we'll start with the first session where we are going to discuss about the regression techniques and their implementation. So in order to do hands-on with me, you need to install two softwares which I have shared in the chat box and through email as well as in WhatsApp group. So there is two software you have to install in your system. One is R interpreter. The size is around 82 MB. So I have specified the version is 4.4, but you can install any version. You can simply go to the link and whatever the latest version is there, so you can download it. But I think the latest version is 4.4.0. And after our interpreter is successfully installed in your system, then you can go for another software that is called as R Studio IDE, which will provide you a better interface to write the code and everything. So you have to download R Studio IDE. The current version is, I think, 3.3.0, and the size is around 263 MB. So these two you have to install in your system one after another. First you install R interpreter, then you install R Studio IDE. Okay. So I'll cover some theoretical aspects as well in this session. So by that time we'll discuss the about hands-on. Make sure that these two things are ready with you, right? So that you can do the hands-on with me. If it is not possible, you can see in what way I am doing in my computer system, and at the point of time, you can explore in your system. So this is the agenda for today and about the first session. So this is the outline of this particular presentation. We'll discuss about the introduction to the regression. Then we'll see one of the simplest regressions techniques, that is called as linear regression, and the extension of linear regression, that is multiple regression. Then one of the very popular, I can say, regression techniques which is used in various industrial application, that is logistic regression. And there is another regression that is called as Poisson regression. So these four regression techniques we will see. But linear regression case, I will spend more time by showing you a hands-on calculation. I'll also tell you how to write the code for linear regression, and I'll tell you two different problems. Then I'll show you multiple regression implementation, then followed by logistic and Poisson regression. But I'll not show you the hands-on calculation of multiple regression, logistic, and Poisson regression due to limited time. Then we'll discuss about the conclusion and references. So in my last lecture, we discussed about there are two different type of machine learning technique. One is we have seen supervised learning. Supervised means there is a teacher, or you can say there is a class level. Another is called as unsupervised learning, for which there is no class level. Okay, and there is no teacher in the case of unsupervised learning. And we have another form of learning also, that is called a semi-supervised learning, which is a combination of supervised and unsupervised learning. But if you go inside the supervised learning, you will find supervised learning techniques can be categorized into two parts. One is regression technique, another is called as classification technique, which we are going to discuss in today's class. And similarly, unsupervised learning is divided into two parts. You can say multiple techniques are there inside that. One technique we are going to discuss in this faculty development program, that is the clustering techniques. Okay, so let us start with the first part, that is a regression technique, as I mentioned. So regression analysis is a set of statistical processes for estimating the relationship between a dependent variable and one or more independent variable. So in regression, we have two different type of variable. One is called as dependent variable, another is called as independent variable. Note that always the dependent variable is one, but independent variable is one or more based upon different types of regression. And what we want to do in regression, we want to establish a relationship between the dependent variable and independent variables. Okay. For example, if I tell you a very simplest one to understand this statement, I can say y is equal to let's say 5x. So in this case, you know, until unless you know the value of x, you cannot determine the value of y. So x is considered as independent variable, where y is considered as dependent variable. So what we are going to establish in regression, we want to establish the relationship between x and y, where x is independent variable and y is dependent variable. So it is a statistical process, we can say. But some sources also refer dependent variable as outcome variable, and some sources also specify the independent variable is also called as predators, covariates, and features. So different sources, if you go through to understand the regression technique, they call these variables with different name. But there is a usually we call that as a dependent and independent variable. Now, if I write a another statement by saying y is equal to, let's say, 5x1 plus 6x2. So in this equation, I can say you x1, x2 value you have to determine in order to calculate the value of y, right or not? So x1 and x2 are said to be the independent variable, where y is dependent variable. Now I think it is clear what is a dependent variable and which one is a independent variable and dependent variable. So you can see in the both equation, whatever I have shown you, y is equal to 5x, y is equal to 5x1 plus 6x2. In this case, there is exactly one dependent variable, that is y. But independent variable is 1 in the first one and 2 in the case of the second one. Similarly, somebody can generalize it by saying that y is equal to 5x1 plus 6x2. Like that, it will go up to, let's say, 10xn. For example, I am saying. So here, number of dependent variable is still 1. Okay, it is only 1. but number of independent variable is n. If I consider x1, x2, x3 up to xn. Okay, so this is the definition of a regression analysis. Apart from it, researcher finds the line or a more complex linear combination, because line is very simple, right? But when you go for a curve type, okay, let it be S curve type or any type, okay, in that case, it is a more complex linear combination. So that must closely fit the data according to a specific mathematical criteria. So you have to draw a line or a equivalent of line or similar to line or alternate to a line such that all the data points, they are fit to that particular line. Right? Suppose I have taken 5 different uh, data points, and I'll tell you draw a line such that all these data points are going to be fit to that particular line. They will not exactly lies in on top of that particular line, okay, but they are very close to that particular line. So we have to establish the relationship, and we have to find a line. We have to draw a line which closely fit with the data. Now, as I said, we are going to discuss about 4 different type of regression technique. So let us start with the first regression technique, which is called as linear regression. So in linear regression, the regression analysis is a very widely used statistical tool to establish a relationship model between two variables. That means in linear regression, you have one dependent variable and one independent variable. For example, if you see the straight line equation, which is y is equal to mx plus c, or y is equal to ax plus b, in this case, if you see x is called as your independent variable, y is called as your dependent variable, and a and b is considered as the coefficient, right? Or they are called as mantisha and slope and intercept. Okay, they are called as slope, another is intercept, or we call it coefficient, or sometimes we call this a constant. Okay, so dependent variable, which is y, is also called as a response variable, and x, which is an independent variable, is considered as a predator variable. Okay, so it is very simple to remember, because all of us know about y is equal to mx plus c. So you can write also mx plus c, but I have represented here as ax plus b, stating that a, b are the coefficient, x is the independent variable, and y is the dependent variable. Now, in order to understand the linear regression, what I'll do it, I'll show you a simple problem statement which we are going to solve using hands-on calculation. So I request all of you to use your calculator, mobile calculator or your desktop calculator, to calculate the value manually. Okay, so that you will understand what is linear regression. Okay, how to make a prediction. Once we are done with that, then I'll tell you uh, how to write the same thing in R programming, which is very, very simple. You don't need any knowledge in R. Simply you install R. I'll tell you from its basic level, so that you'll understand how to implement linear regression using R. So this is the problem statement which I am going to discuss with hands-on calculation and using R. So let us understand this problem statement. So last year, for example, if you consider all of us are belongs to let's say academician or industry. So you know the last financial year or academic year is 2023 and 24. Okay, if you consider this this academic year is going to start in July, that is 24-25. So last year, 5 randomly selected students took a math aptitude test. So, in each semester we have some courses, right? So similarly, from last year result sheet, we collected the results of only 5 students. Why 5 students? Because for illustration, if you take more number of students, it is difficult. You need more calculation, right? That's why simply I have taken only 5 different students so that you can understand how linear regression works. Once you understand, you can run. You can take the data of 5 billion students and do it, right? So 5 randomly selected students took a math aptitude test. So they appeared for math aptitude test before they began their statistics course. Like you can say for statistics course, the prerequisite is our math aptitude test. Okay. For statistics test, the prerequisite is your math aptitude test. So you have collected the results of the students who appeared for math aptitude test before they start their statistics course, and you have also collected how much score they got in statistics course. So both course, math course case and statistics course case, you have the data of 5 different students, but this is not current year data, this is the last year data. Now the statistics department is asking you 3 questions which you are going to solve using linear regression technique. The first one is, what linear regression equation best predicts statistics performance based upon the math aptitude test? So I told you the linear regression equation is y is equal to ax plus b, or it is equal to y is equal to mx plus c, straight line equation, right? So what we have to do here, uh, y is equal to ax plus b. So you need to determine what is the value of a, what is the value of b. And if I give the value of x, x value is nothing but the score secured in the math aptitude test. And y value you will get the score you secured in the statistics course. So y is said to be your dependent variable, x is said to be independent variable. Okay. So y is equal to ax plus b. You have to determine the value of a, value of b, and if you have some knowledge of x value, then you can predict the value of y. First, we need to formulate a linear regression equation. That is our first question. The second question says that if a student made an 80 on aptitude test. So math aptitude test means it is saying x value is equal to 80. Okay, if x value is equal to 80, math aptitude test is 80, right? So if a student made 80 on the aptitude test, then what grade would we expect his her to make in statistics? So if x is equal to 80, you have to determine what is the value of y. Okay. Then next one is, how well does the regression equation fit the data? That is very important question in data science perspective as well as machine learning perspective. So once you design a regression equation, how well this particular equation fit with the data. Okay, I am designing a linear regression equation. Not necessary that it is going to fit with the data, right? That's why it is saying that how well does the regression equation fit the data. So these 3 questions we are going to solve by taking the data of 5 different students. So here, as I mentioned, xi, as I am taking 5 different students, I consider xi is an independent variable where the I value lies in between 1 to 5. Yi is my dependent variable where again the I lies between 1 to 5. Remember, x is called as your math score, okay, or we call it math aptitude test. Yi is said to be your statistics grade, right? So what we have done is the total mark in the statistics and math, it is out of 100. So we generate the scores out of 100. Generally, I mentioned that the last year data we have collected. Let's say the data collected last year is this data. Okay. So let me take a new page and I'll show you this thing so that it's more clear. Yeah. So I am taking XI. First I am taking student, or you can say student ID is 1, 2, 3, 4, and 5. Xi is my independent variable and I'm taking the value as 95, 85, 80, 70, and 60. Yi is my independent. Yi is my dependent variable. Xi is independent. Yi is dependent. So the values are 85, 85, 95, 70, 65, and 70 respectively. Okay, and you know our equation is y is equal to ax plus b. Okay, so what we have to do in order to determine the coefficient a and coefficient b? So there is a formula. So if you want to calculate coefficient a, it is nothing but summation over xi minus x bar. X bar is nothing but mean of x. As we are taking 5 different students, mean of x is nothing but average value secured by 5 different students in a particular subject. And yi minus y bar, okay, divided by sum of xi minus x bar whole square. Okay, so using this one, we are going to calculate the regression coefficient, that is a. Okay, so but we have only the value of xi and yi. So first we need to determine the value of x bar and the value of y bar. So value of x bar is nothing but 95 plus 85 plus 80 plus 70 plus 60 divided by 5. So can anybody calculate the average value using your calculator? All of you know how to calculate average. So can you please calculate the average value of x, that is 95 plus 85 plus 80 plus 70 plus 60. Can anybody calculate? You have to sum these 5 values. The sum I think you will get is 390. Sum is 390. Yeah. Benita madam answered it. Yeah, 390 is the sum. And if you take average by divided by 5, okay, so you will get the value is 78. So thank you, Benita madam and Anita madam, Lakshmi madam. Okay, all of you got. So I am writing the x bar is 78. Similarly, you can determine the value of y bar. Y bar is nothing but 85 plus 95 plus 70 plus 65 plus 70. It is 385 divided by, if I do 5, then how much you are getting? Can anybody tell? Write in the chat box also. Yeah, most of you got 77. Okay, so I'm writing 77. Okay, so I have determined xi and yi value. So these two values are known to me now. And you know what is xi and yi values. So first you need to determine here, that is xi minus x bar, right? Then you have to determine yi minus y bar. Then you have to calculate xi minus x bar multiplied by yi minus y bar. Okay, then I have to calculate xi minus x bar whole square. Then you will calculate the value of a, right? If you see this formula, I have to calculate these many calculations. Okay, so what we will do, we'll start with the first one. So xi is 95. X bar we have calculated as 78. So it is 95 minus 78. Similarly, it is 85 minus 78 for the student 2. Then 80 minus 78 and 70 minus 78 and 60 minus 78. So the value may be positive or the value may be negative. So nothing to worry. Don't think that if you are calculating wrongly, if you are getting the value is negative. Okay, so you are getting 95 minus 78. If I calculate, I am getting the value is 17. So this value is 7. This value is 2. Here I am getting negative value. Here also I am going to get negative value. Right? Similarly, you can calculate yi minus y bar. So I can write 85 minus y bar is 77. Similarly, I can write 95 minus 77, 70 minus 77, 65 minus 77, and 70 minus 77. Okay. So if you solve this one, so you will get 8 here, you will get 18 here, you will get negative value here, here again negative value, here also we are getting negative value. Okay, so we got xi minus x bar and yi minus y bar. Yeah, it is already given in the chat box also by Lakshmi madam. I thank everyone for responding. Okay, but our objective is not to do xi minus xr, yi minus y bar, right? If you see the numerator, we need to find xi minus x bar and yi minus y bar, and that is also not our objective. Okay, our objective is to sum all these values, right? Okay, anyhow, we are doing step-by-step process. So if you calculate here, so I can say xi minus x bar into yi minus y bar is 17 into 8 and 7 into 18, 2 into minus 7, minus 8 into minus 12, and minus 18 into minus 7. Okay, so this multiplication you have to determine. So 17 into 8, we know it is 136. 18 into 7 or 7 into 18, you will get 126. Yeah, it's correct. It is there in the chat box also. I think the second value you can check, madam. It is, I think it is 126. I don't think that it is 56. Okay, so next value is minus 14. Okay, here two minus are there, so it is positive. 12 into 8, we know it is 96. And 18 into 7, it is 126. Okay, so we got the xi minus x bar and yi minus y bar. And as I told you, our objective is not to find this one, our objective is to find its sum. So if you calculate the sum, so 136 plus, you can use your calculator, 136 plus 126 minus 14 plus 96 and plus 126. So you will get the value is 470. Yeah. Yeah, most of you have responded. Vinita madam and Aksu. Lakshmi madam answered 470. So our numerator is now solved. So numerator is 470, right? But now we'll go for denominator part. So in denominator part, it is xi minus x bar whole square. So xi minus x bar you have calculated already. So you have to make it square. So square means it is 17 into 17. Okay, then 7 into 7, 2 into 2, minus 8 into minus 8, minus 18 into minus 18. As you are determining square, so the value will definitely be positive. Okay. So 17 into 17, it is 17 into 17, you will get 289. Okay. 7 into 7, you will get 49. 2 into 2, you will get 4. 8 into 8, you will get 64. and 18 into 18, I think you will get 324. Okay. Okay, so xi minus x bar also you got square, but again you can see in the denominator part, it is sum, right? It is a sum, right? So you have to add all these values. So all of you add this value and please let me know what is the value you are getting. Yeah, it is 730. Yeah, 730. Okay, you will get the value is 730. So denominator also we got 730. So if I put this one, I'll get the value of A. So 470 divided by 730, you will get 0 point something, right? As our denominator is more than the numerator. So what is the value we are getting? 0. Yeah, 0.6438. You are correct. Okay. You may, somebody can take 2 decimal plus 3 decimal place. Okay. Like the maximum digit what I can see, that is 0.6438. Okay. So let me check once. Yes, 0. You are correct. 356. Okay. And I am also getting 16. Okay, anyhow, you can take 2 decimal place, you can take 4 decimal place. Somebody has taken 3 decimal place. So based upon that, your values are going to be little bit different. So nothing to worry, right? Because it is we are forming the equations, right? So you will slightly get a different value, right? So now we got the value of A, right? So our equation is y is equal to ax plus b. So which I can write here that y is equal to a value I can put, right? That is 0.6438. Okay, let me take four digit, which is usual. 0.6438 x plus b. But I also want to find the value of b, because first we need to determine the coefficient values. So if I want to calculate the value of b, we know it is y minus 0.6438x. Okay, y is equal to b is equal to y minus 0.6438x. But if you talk about this particular data where we have taken 5 different students math score and statistics score, so we got x bar is 78 and y bar is equal to 77. So here the value of x is nothing but what we got as a average value. The value of y is nothing but what we got as a average value of y, right? So if I put that value, y is equal to 77, so I'm taking this particular value, minus 0.6438, x value is 78. Okay, so if you calculate this, you will get the value of b. So I think you will get a big value, not a decimal value. So let me calculate. 77 minus 0.6438 multiplied by 78. Yes, most of you have answered. That is 26.7836. Okay. So if you take more decimal place, for example, I am taking 0.6438 35616. Okay, if I take this last value, I am going to get b value as 26.780822. Okay, so I can say 26.78 from all perspective. If I take 2 decimal place, it is same for everyone. So now y is equal to ax plus b can be written as y is equal to a value as 0.6438, okay, x plus b value is, I am taking this particular b value 26.7808. Okay. So this is my linear regression equation. So if you go back to our problem, which I told you here, what linear regression equation best predict the statistics performance based on math aptitude score? So you can say y is equal to 0.6438x plus 26.7808 is the linear regression equation which best predicts statistics performance. Okay, now our first question is solved. Okay, although it is a too much calculation, but don't worry, when you go for R programming, you will get you will get this one is very easily, right? This value of A, value of B, you will get very easily. Okay. But my idea is that not only the functions you should use to generate the value of A and B or any regression, but you should know that how manually also you are going to calculate it. Okay, is a part of this course. Okay, anyhow, the second question will move, which says that if a student made an 80 on aptitude test, our aptitude test is nothing but, as I mentioned, it is X, and statistics course I have mentioned that is Y. So it is saying if X value is equal to 80, which is our math aptitude test, then what grade or what mark would you expect his or her to make in statistics? So it is very simple. You know the linear regression equation. You know the X value is equal to 80. So we can easily calculate. Okay, we can easily calculate what is the value of Y. How to calculate? You have to simply put y is equal to 0.6438 multiplied by 80 plus 26.7808. That will give you the value of y. Okay, can anybody calculate and tell me? Yeah, most of you got 78 point something, right? Yes, if you get 78 point something, maybe you will get little bit variation in the after decimal point. So you should get 2848 if you consider all the decimal places. Otherwise, 78 point is something, okay, is acceptable. Okay, so now we got the value of y. So our expectation is that the student who secured 80 marks in math aptitude, the student is going to secure 78.2848 in the course of statistics. But I'll show you the data, what we have calculated. You remember what is the X value we have taken here, that is 80. So if you go here, you can see there is a sample where X value is equal to 80, right or not? So if you see in the student 3 case, what is the X value? X value means it is the math aptitude test value. The value is how much? It is 80. But what YI value we got? The value we got is 70 in this case, right? But what y value you calculated based upon the linear regression equation? That is 78.2848. So in your data, where x is equal to 80, y is in your data, it is given as, y data is given as 70. Right? Y is given as 70. Right or not? But we are getting y value using linear regression equation is 78.2848. So remember, this is a model, right? Linear regression is a model. Model is trained based upon the data. Okay, once model is trained or once the linear regression equation is formulated, we are no more dependent on the data. We are no more dependent on the data. We are not doing matchmaking process. In matchmaking process, what we are doing? We have to check that where we got x value is 80. Then we will go for the next immediate column and I can say y value is 70. But actually we are not doing that. We are not doing that, right? What we are doing here, that we have formulated a linear regression equation based on we predict that if a student secure x is equal to 18, then y value is 78.2848. Okay, so there is a concept here which in machine learning we say that is called as error. We call that as a error, or in this term we call that as a residuals. So residuals are nothing but actual y value minus predicted y value. So in this case, if you see, okay, actual y value is 70 and predicted y value is 78.2848. So your residual becomes minus 8 point. Your residual becomes minus 8.2848. Okay. Not necessary that you are getting only case of 80. You put any value, whatever you have observed here. You put 95. If you put in the 95 in this equation, how much you will get? So let me tell you the linear regression equation you can calculate, right? The linear regression equation is y is equal to 0.6438x plus 26.7808. So in this case, if I take x is equal to 95, then I can write y is equal to 0.6438 multiplied by 95 plus 26.7808. Okay. So now, can you tell me what is the value of y? What is the value of y you are getting here? Yes. Somebody has replied 87. 87. Are you all of you are getting 87? Okay. Let's say you are getting 87.9418, but the actual value you are getting is 85, right? So I can say residual can be calculated as actual value is 85 minus 87.9418. So I'm going to get the value is minus 2.9418, right? So for any particular model, if actual value is equal to the predicted value, so what we can say? Whatever we have predicted, that is correct, right or not? Somebody can say that tomorrow there is a heavy rain, and actually we felt that that we can only feel once the event is occurred, right? So we have seen that yes, there is a heavy rain. So what we can say? Whatever prediction you have given, that is correct, right? But if there is no rain, then we can say our prediction is failed. So always we try to minimize actual minus predicted, or sometimes we say that predicted minus actual and we put a modulus. Okay, error case, instead of saying negative positive values like residual, in error case, we put a modulus so that all the values it will come in positive. Either actual is differing the predicted one, or predicted is differing the actual one. Right? Okay, so now what we will do, this calculation also I have given here. You can see in this slide, I have calculated xi minus x bar, yi minus y bar. Then I have calculated xi minus x bar whole square. Anyhow, yi minus y bar whole square is not required. Then we have calculated xi minus x bar yi minus y bar, which we have calculated. And I have given the value of a here. I have given the value of b here. And I have written the linear regression equation. Okay. Now, I also showed you that if you put the value of 80, you are getting the value is 78.2848. Right? So up to this we have discussed. Now, if you remember, what is our third question? Our third question is that whatever analysis we are doing, right, in this linear regression equation, how well does the regression equation fit with the data? Okay, so if you see here, I'll show you here. If you go to the data, let's say I'll show you here. What is the range of xi? Range is nothing but, let's say, the minimum value to the maximum value. Minimum value to the maximum value. So out of these 5 values, the minimum value is 60 and maximum value is 95. Right? Similarly, if I ask you what is the range of yi, you will say the minimum value I got is 65, this one, okay, and maximum value out of these is 95, right? So in your data, you found the range of xi and the range of yi, right? But you have not seen any value outside this particular range. You have not taken any value outside this particular range. But while you are training, this is the minimum and maximum value, or I can say range. But while you test a model, this is training a model. Okay. Just imagine that in a book, as a teacher, you have covered page number 60 to page number 95. But in exam, you are putting a question. Okay. Let's say that concept is available beyond this particular range. Right? So in that case, what happens? Students will say that this is a out of syllabus question, right? So if you, when you test a particular model, if you are putting any value outside the range which you observed in the training process, so it will give you a unreasonable estimate. Okay. Alternatively, I can say when you use a linear regression equation, don't use any value for the independent variable, that is xi, that are outside the range of values used to create the equation. So independent variable is more important. Dependent variable is dependent on independent variable. So instead, if you have taken the value in the range of 60 to 95, make sure that all values you will put in the range of 60 to 95 in the testing page. If not, you will get a unreasonable estimate, or we call that as a extrapolation. Okay. And sometimes this outside the range is very, very problematic. So you have to ensure that all the test data points, whatever you want to get, okay, whatever you want to predict, their corresponding yi value. So you will not get any value outside the range. Okay. So this is the answer for the third question, that how will the regression equation fit with the data. So don't try with any value which is outside this particular range. Okay, anyhow, now we are going to implement this using R. Okay, so I hope some of you have installed R Studio in your system using the link which I have provided. So you can open your R Studio in your computer system. So R Studio will work in the front end, and back end we have R interpreter, which is going to execute my R programming code. Okay, so all of you open R Studio. Simply, if you have installed correctly, then you open R Studio, you will get this particular screen. Okay, so I don't have letters. I don't have any updated version, so it is reminding me. I have opened some other files. Let me close it. So you will get this screen. If you are getting this particular screen, so I think everything is fine for you. Okay. So now you are present in console. You can see here it is written console. It is written R version is this one. I am using a old version, but I told you to install the latest version. Irrespective of the version, you will get the same output. Nothing to worry. And in order to clear the screen, you have to press Ctrl and L. Ctrl plus L to clear the console. Okay. Ctrl plus L. Okay. Simultaneously, you have to click to clear the screen. Okay. So you can write your code in console, but it is not always good to write the code in console. So you have to create a file and write the code. That will help you to modify the code repeatedly. If you did any mistake while you are writing code, then we can modify that, right? So I'll go to file, and if you go to new file, and it is showing R script. In R, we call that is a script. So I am clicking R script. So now you can see my screen is divided into two parts. Okay, first part is divided into two parts. Console is here, and I have opened a file, right, without its name. So let me save this file with the name. Okay, by default, the files are going to be stored in the document folder. But let me store all these files under our material folder so that you can access to this code. So I'm writing linear_reg. Okay. And I'm saving that file, the blank file. Okay. So my file name is linear_reg, which indicates that linear regression, and it is a R file. So the extension of R file is .r. Okay. So now I'll tell you how to implement linear regression. It is very, very simple. Only you have to write 4-5 lines of code to implement the linear regression. So, we have taken 5 data points. What are the data points we have taken? If you remember, I have noted down here. That is 95 I have taken, 85 I have taken. I am putting comma to separate one value from another value. 80 is another value, 70 is another value, and 60 is another value. Okay. So all of you know I have taken these 5 values for my independent variable. So what I'll do, I'll put this in a bracket. Okay, I'll put this in a bracket. In R, we have a function called C function. C function. So function, we are writing function name followed by a parenthesis start and parenthesis end, right? So in R, we declare a vector using C function. So if I write C, so it will be turned as a C function. So I have taken a set of values separated by comma. I put within a bracket, and I am writing C. C is a predefined function to define vector in R. And let me store this vector with a variable of your choice. Simply we can take xi or x. Okay. So these are the x values. X is equal to C of 95, 85, 80, 70, and 60. What it indicates? It indicates that 5 different observations of independent variable which is put in a vector. Is it clear? What is the meaning of X is equal to C of 95, 85, 80, 70, and 60? Okay. Similarly, what I can do, I can write the value of y. Y is another temporary variable or variable. I want to mention the values which I got for dependent variable. Okay, that is 85, 95, 70, 65, and 70. Okay, so these values we have taken in 2 different columns, if you remember. So I am writing this with 2 different variables. X is considered as an independent variable, y is considered as a dependent variable. So in R, we have a predefined function. The function name is LM. LM stands for linear model function. LM stands for linear model function. So linear model function is used to create a regression model. Okay. LM is a function to create a regression model. So I am writing LM y. Y is my dependent variable, is a function of independent variable. We are writing y is equal to f of x. Y is equal to f of x. So if you put the x value in the function, then you will get the value of y. So lm y, this tilde character, this is called as tilde character, which indicates that y is modeled as a function of x. Okay. So sometimes if you have more than one variable also, you can write y tilde character x1 plus x2 plus x3, or you can write y tilde character x1 multiplied by x2 multiplied by x3. Right? You can write like this. So lm y tilde character x. So I put this in another variable. Let's say the variable name is relation. You can give any variable name. Okay. You can put the name as relation. Then I can print the relation. Print the relation. Okay. Print the relation. Okay. So in R, you can see there is a run button here and there is a source button here. You can select source with echo to run the entire code. You can use run button to execute a particular line. For example, I am putting my cursor here before X and I am clicking run. So you can see automatically when I click run, so X is created. Okay. And the cursor is moved from X to Y. Okay. Similarly, if you go for environment, so let me clear the environment so that you can see this more clearly. And I will clear also the console. And I am putting my cursor again before X. Okay. So now if I click run, you can see under environment, a X variable is created. Okay. Then when I click again the run button, it is moving from the second line to the third line and Y variable is created under the environment. Okay. And when I execute the relation, then you can see, okay, relation, you can see another data is created here, which is called as relation. And when I print the relation, it is showing the X coefficient is 0.6438 and Y our B. Okay, we have Y is equal to AX plus B. So X coefficient is A. So A is 0.6438 and B is 26.7808. Okay. So whatever you got A value and B value, now you are getting the same A and B value by writing only 4 lines of code. Okay, let me share this code with you in chat box also. So you can directly copy. Okay, so linear model function is now created. LM function is used to create a linear regression model. Okay. So here you can also say that Y is modeled as an additive linear function of X. And if you want to know more about this particular relation, then I can write print summary of the relation. Summary of relation. And if you execute it, you will get more details about this particular relation. Okay, so this is more details about the relation. For example, I told you residuals. The meaning of residuals I told you. Residual is the difference between the actual value minus predicted value. So you got these are the values, which is nothing but the difference between the actual value and predicted value. So as you have 5 samples, so it is displaying the values of the 5 samples. So when you have more samples, for example, you are dealing with 10 samples, 20 samples, or more than that, So in that case, it is going to represent in the form of a 5-number summary. So I'll tell you 5-number summary in my another lecture. There I'll tell you about various visualization technique. So in that lecture, I'll tell you what is 5-number summary. Just you can do one thing. You can simply copy these values and paste one more time here. I'm copying these values and putting another time here. And if I run the entire code, you can select and run, or you can simply click source. So you can see it is showing the values in 5-number summary. That is nothing but the minimum value, first quartile, median, which is second quartile, third quartile, and maximum. Okay. Okay, anyhow, that is clear. So what I'll do, I will only stick to 5 samples so that you can understand more better way. Okay, now you can see some other things are also showing here, like 0.6438 is the coefficient of x and b value is 26.7808, which we call as estimate. Apart from estimate, it is also showing you the standard error, t value, and PR, which is greater than mod t. So this value we are also getting. So for this, you need not worry. For each and every thing, we have a mathematical formula, right? So you can also see another important observation here, which I forgot to mention you. If you sum all the residuals, these are the residuals, right? So if you sum all the residuals, so sum of all residuals you will get, it is equal to 0. So if you sum minus 2.945, 13.493, minus 8.288, minus 6.849, and 4.589, okay, you will get the sum of these all these values is equal to 0. And this t value is simply calculated as the ratio between estimate and standard error. Okay. So 26.7808, 26.7808 divided by 30.5182. So you'll get the value is 0.878, and 0.6438 divided by 0.3866, you will get the value is 1.665. Okay. So for standard error also we have a formula. Okay. For residual standard errors 10.45, you are getting in this case. For that also you have another formula, right? And degree of freedom is calculated. You can see here degree of freedom, as you have taken 5 different students. Okay, 5 different students you have taken and 2 variables you have taken. One is x variable, another is y variable. So 5 minus 2 is your degree of freedom, that is 3 degree of freedom. And in order to calculate the residual standard error, you have to use a formula which is root over of summation of e square. E is nothing but your sum of residuals. Okay, E is nothing but individual residual square divided by n minus 2 divided by sum of xi minus x whole square. So it is a very long formula. So if you calculate that, you can get the standard error value, and residual standard error value also you can get by doing root over of summation of e square divided by n minus 2. Okay, in this way you can calculate it. Similarly, we have multiple r squared value, adjust r squared value, f statistics value, and p value. So in statistics, so p value in statistics, generally p value is also always considered as 0. It should be below 0.05. As we are taking 95 confidence interval, we normally consider that the value should lie below 0.05. So if the value is greater than 0.05, then there is no significant relationship between two different variables. Okay. Any doubt in this? Okay, so this is about linear regression equation, but till now I have not told you about the prediction. So I'll tell you another example quickly, then I'll tell you the prediction. So I'm creating another script and I am going to rename it with another name, that is linear underscore regression 1 dot r. Okay. So here what I want to do, for example, I'll solve another problem in which I am considering the height of, let's say, 10 persons and weight of 10%, and I want to establish the relationship between height and weight. Okay. So what I'll do, I'm taking x is equal to, let's say, height of 10% is, let's say, 151, 174, 138, 186, 128, 136, 179, 163, 152, let's say 131. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have taken the value of 10 different persons' height. Similarly, y is equal to C of 63 is the, let's say, weight of the person, first person, 81, 56, 91, 47, 57, 76, 72, 62, and 48. Okay. Let's say this is my independent variable and y is considered as my dependent variable. X is independent and y is dependent. Okay, so in order to establish the relation, I told you you can take any variable. Let me take a variable relation is equal to LM is linear model and y is a function of x, and I will print relation. Okay. So if you run this code, let me clear my console so that you should not confuse with previous output. So if I run it, and I'll show you here, it is taking x value here, y value here, it is creating a relation, and if I print that relation, it says that the coefficient of x is 0.6746 and the value of b, which is intercept, x is nothing but slope. Okay, 0.6746, which is the coefficient of x. Okay, it's called a slope. Intercept is minus 38.4551. Okay, minus 38.4551. Okay, so now if you want to know more about this particular relation, what you will write in R? Can anybody tell? I told you in the previous one. If you want to display more about a particular relation, what command we are writing in R? We are writing print summary of relation. Okay, so if you run it, then you will get detail about this relation. Here you can see the number of samples we have taken, it is more than 5. Okay, so in fact it is 10. That's why here it is showing in the form of 5 number summary. And we are getting estimate, we are getting standard error, we are getting p-value, we are getting residual standard error, we are getting degree of freedom. Degree of freedom is that here I have taken 10 different persons' height and weight. So we have taken 10 different person and number of samples I have taken is 2. One is x, another is y. So 10 minus 2, it is 8. Okay, and we are also getting multiple r squared, adjust r squared, f statistics value, and the p value. But here you can see in the previous case, the p value is, I think it is coming as 0.19 something. okay, which is greater than 0.05. But in this case, the p-value is coming as 1.164 e to the power minus 0.06, which indicates that the value is below 0.05. So as the value is below 0.05, so there is a significant relationship between the variable x and the variable y. Okay, and apart from this one, the previous one, if you compare, then you are getting significant code. Okay, here you are getting significant code, right? So if you look into the significant code, what it indicates, if the value is in between 0 to 0.001, okay, you can see the last column, okay, before this star column. If a particular value is in between 0 to 0.001, then we represent it by a triple star. But if the value is in between 0.001 and 0.01, we represent it by a 2 star. If it is in between 0.01 and 0.05, then we represent it by a single star. And if it is between 0.05 and 0.1, we represent it by a dot. And if it is 0.1 to 1, then we represent it by a blank. So in this case, you can see 0.00139 lies between 0.001 and 0.01. That's why we represent it by 2 star. Similarly, this particular value lies in between 0 to 0.001. That's why we represent it by a 3 star. So I think you understood this one. Now I'll tell you how to make the prediction. Okay, prediction is more important, right? Like in the previous one, I have given a value for math aptitude test and you have predicted for statistics course. Okay, you have taken the one value of x and you put in the linear regression equation and you got the value for y. Similarly, in this case, also you can take a person's height in centimeter and you can predict what is the weight for that particular person. Okay, but how to do it in R? That is more important. So for that, in R, we have a function that is called as predict function. For example, if I ask you, suppose a particular person height is equal to, let's say, 170 centimeter, and I want to predict what is the weight of that particular person. So for this, in R, there is a predefined data type I am taking that is called as data frame, where I am mentioning x is equal to 170. Okay, and let me assign it to a variable a, and I can write the predict function which takes two arguments. One is relation. Relation is our linear regression equation relation, and I'm writing the data frame which I have stored in A. And let's say I am storing with another variable. Let it be result. So I have taken a value of x as a data frame and stored in A. I am using the predict function. Predict function takes two different parameter. One is the linear regression relation, which I stored in relation, and the value a, where the data frame is there, and I'm storing in result. So now if I print the result, then I will get some value, right? So if I run it, then you can see it is showing me that if a person's height is 170 centimeter, then the weight of the person is 76.22869. Okay, if height is 170, then weight is 76.22869. For example, if I take this particular data, here you can see the data is 151, right? So if I put 151, can anybody tell whether I'm going to get 63 or not? Are you going to get 63? If a person's height is 151, which you have trained a model and its equivalent weight value is 63. Now in testing phase, you are again giving the value is 151. Are you going to get the value is 63? Please respond. Obviously, some error will be there. Okay. So if I execute it, it is showing the value is 63.41109. So error is very minimal, right? That is 0.41109. This is nominal. Okay. So if error is reduced to 0, that means your prediction is the actual one. Right? In this way, you can make prediction in any model. Not only that, prediction, you can do prediction of multiple values also at a time. Okay. Suppose you have trained your model with 10 billion data and you want to predict by giving 10 values. That is also possible, right? But make sure that the samples, the number of values you are taking in the testing phase, which is quite small compared to the number of values you are taking in the training phase. Because we know training is quite more compared to the testing. Okay. So now we'll see another interesting part. I told you in the regression definition, not only we are establishing the relationship between the dependent variable and independent variable, but also our objective is to establish a relationship in the form of a line or a complex relationship. Okay, so we'll see how to do this one, right? So for that, what you need? You need graphical representation or data visualization technique, right? You know there are various type of data visualization techniques are there: pie chart, bar chart, line chart, histogram. Although we have an explicit session on that, but we'll see how to represent this data, this small data, okay, in the form of a chart, right? A straight line. How to draw a straight line with this height weight regression relation, okay, and how to visualize these data points with a straight line. That is our next objective. Yeah, anybody is having any question, you can ask. I think there is a hand raise. Okay, it may be by mistake. Okay. So what I'll do, remember, if you want to go for any data visualization technique, then first you have to create a chart file. So in order to create a chart file, so once you have formulated the relation, okay, let me otherwise create a new file, copy this content, and I am storing it with another file by saying linear regression underscore visualization. Okay, so I have established the relation here. Now I want to show this relation in the form of a chart file. So in order to create a chart file, you have to use a function that is called as PNG function. You can see while you are typing PNG, it is showing what are the parameters it has. Okay, we are not familiar with all the parameters and we need not be, right? Based upon our requirement, we can formulate different type of, we can use different type of options, right? So I'm creating a file with the name, let's say linear underscore, or let me write a very simple one, linear dot or linear regression, simply let's say linear regression dot png. Okay, so what this line will do, this png function will help you to create a chart file, and the name of the chart file is linear regression dot png. Okay, you can also write extension as jpg or whatever format you know, or jpeg, something like that. Now in order to plot, so there is a predefined function plot through which you have to plot the chart. So I am taking y and x. Y is my dependent variable, x is my independent variable, and let's say I want to show all these data points in red color, right? And I want to give the name of this chart as height and weight regression. Any name you can give, that will be displayed on top of the chart. And there is a function to draw the line that is called as AB line. In AB line, it is a function, okay, that is used to add one or more straight line. Under AB, inside the AB line, I want to write this relation, that is x is a function of y, okay. And suppose you want to specify the x level, so you can write x level is, let's say, weight in, let's say, kg. And if you want to specify y level, so I can write y level is height in centimeter. Okay. So I'm again telling you y is our dependent variable, x is my sorry, y is my dependent variable. Yes, x is independent variable. I want to represent all these points in red color, and I'm mentioning the name of my chart is height and weight regression, and I'm using AB line function to draw the line, right? And I'm establishing the relation lm is a function lm x tilde y, right? And I'm mentioning the x level is weight in kg and y level is height in centimeter. And in order to save this chart, I can write dept dot off. Okay, so you can see in any data visualization technique, these two lines are same. One is this PNG line, right? PNG is a function, and devof is another function to save the file. So by default, if you go to your document folder, this is my document folder. You can see in my document folder, there is no file called linear regression.png. There is no file, right? So when you execute it, so here I am executing. Okay, here I am executing. So you can see one file will be created here with linear regression.png. So by default, our folder is the document folder. So if I open it, then you will get a line graph like this. Okay. So where these dots represents what? Our data points. How many data points it is showing here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data points are there. So weights are given in the x-axis in kg. Heights are given in centimeter in y-axis. And these are the points. And this is the line which closely fit with our data. So as we have taken only 10, it is depends upon the data of 10 different data points. But normally you can see the number of data points are very, very huge. Right? So in this way, we can visualize a linear regression equation in a line graph. Is it clear? All of you are getting this graph? Can anybody respond? If you are doing with me in your R Studio. Okay, if you have not installed R Studio in your system, nothing to worry. You can install later and follow my video so that you will get in the document folder. Yeah, can you show the code? Okay, this is the code. In fact, this code is already saved in the material folder. You can directly go to material folder and copy the code. Okay, still, if you are doing here, let me paste it in my chat box. So that will help you. Okay, so the code is very simple. You know these three codes in from the first script. Only I have added these three lines. In these three lines, nothing to worry. Okay, because the first line and last line is common for all type of data visualization technique using R. Whether you want to do a scatter plot, or you want to do with a box plot, or you want to go for pie chart, line chart, bar chart, whatever we have seen from our childhood, these two functions are same. PNG function is used to create the chart file. So PNG function is not limited to .png format. That is not true. .png format, not like that. If you want in .jpg also, you will write PNG function. Okay. And plot function is used to plot the graph where we have mentioned y, x, and a b line. Okay, these are optional. The title of the graph, x level, y level, which we got. If you don't want to mention also, it is fine. It is not a compulsory parameter. It is an optional parameter. Okay, only AB line is compulsory, and the supplying the value of x and y axis values, that is compulsory. Rest is optional. Okay, so in this way you can implement the linear regression equation. So as a summary of linear regression equation, I can say we discussed about how to get the value of A and B with hands-on calculation. We also have seen once you calculate A and B value, how to predict a value. Okay, with a given x value, you have to predict the value of y. And we have also discussed about how linear regression equation fit with our data. Then I showed you an example where I mentioned about height and weight and relationship between and height and weight. And we have also shown, I have also shown you, and we have discussed that what is the use of predict function. Then in the last, we have discussed how to plot the graphs in linear regression equation. Okay, so now what I'll do, I'll go to the next regression. Okay, anyhow, all these things I mentioned in the slide, you can go through it. Okay, the next regression which we are going to discuss, that is called as multiple regression. So the difference between the linear regression and multiple regression is that obviously we have only one dependent variable, but in multiple regression case you have more than two or more than two variables. So multiple regression is said to be the extension of the linear regression equation or the relationship between more than two variables. Why we are saying more than two variable? Because one dependent variable will be there, one independent variable is there. So minimum variable is two. So multiple means number of variables is greater than two. But how many dependent variables are there? Only one. How many independent variables are there? Greater than equal to two. Okay. So we have more than one predictor variables and one response variable. Response variable, I told you, it is called as dependent variable. Okay, and predictor variables are called as independent variable. And the formula, sorry, the equation which we are using for multiple regression is that y is equal to b0 plus b1 x1 plus b2 x2 up to bn xn. So for this equation, if you take this particular part, then it is a linear regression equation only, right? So instead of a, I am writing b0. Instead of b, I am writing b1. Okay, and instead of x, I am writing x1. So if you generalize the linear regression equation, you will get multiple regression equation. So y is equal to b0 plus b1 x1 plus b2 x2 up to bn xn. So y is your response variable. b0, b1, b2 up to bn, they are called as the coefficient. x1, x2, xn up to xn is called as predictor variables. Okay. So now again, I'll tell you a problem and step-by-step process, but I will not do the hands-on calculation due to time limitation. But I have given hands-on calculation in my presentation, which you make your use while you are teaching to your students or for understanding the multiple regression. So multiple regression, which we are going to see here as a first example. I'll show you two examples. In the first example, we will do with two independent variables. So if there is two independent variable, total number of variable is 2 plus 1. right? Because there is only one dependent variable. And if there is two independent variable, it is 2 plus 1, that is equal to 3. So this problem statement, what we are going to address, we have to predict the job performance of a semi mechanic. Okay. So forget about this job performance. Suppose in a particular interview process, okay, you have phase 1, let's say phase 2. So a candidate has to appear phase 1, then phase 2, then based upon that, you are going to select a particular candidate. Okay. So phase 1 is considered here is in this particular problem is mechanical aptitude test. Okay, there is an aptitude test. So based upon that, a candidate has to get some mark. Second is called as personality test. First, you have to appear for mechanical aptitude test. Second, a candidate has to appear for personality test. Then you can analyze the performance of a particular candidate. Okay, so it is represented as X1 and X2. Math aptitude test score and test score from personality test that measure conscientiousness that is given to you. Okay. Now, if it is complex, simply assume that phase 1, phase 2, based upon that, you have to analyze the performance of a particular candidate for a job interview. Okay. So now let us examine. So for examine, you have to take some candidates data. Like in our first example, we took marks. Second example, we have taken height and weight. So here in the below table, okay, you can see I am showing you the data of 5 different candidates. Okay, so I want to mean that this is your candidate 1. Let me represent by C1. This is candidate 2, candidate 3, candidate 4, and candidate 5. So in the candidate 1 case, X1 is nothing but phase 1. X2 is said to be phase 2. And candidate 1, let's say, scored 3 in X1, 8 in X2. So the overall performance is, let's say, minus 3.7. Not necessarily we are adding or subtracting or something like that. Some function we have designed which is giving us minus 3.7. For candidate 2, X1 is 4, X2 is 5. So Y value we are getting is 3.5. Similarly, we have for candidate 3, candidate 4, and candidate 5. Right? And as there are two independent variable, so what is our multiple regression equation? Our multiple regression equation is Y is equal to B0 plus B1 X1 plus B2 X2. Okay, so B0 is what? B0 is a coefficient, B1 is another coefficient, B2 is another coefficient, and X1 is your independent variable 1, X2 is your independent variable 2. Okay, so in order to determine B0, so B0 can be written as B0 is equal to Y minus B1 X1 B2 X2. And if you are taking multiple student, you have to calculate the mean value. That's why I'm putting bar. In the first example also we have seen it is given with 5 different students. So I'm calculating their average one. And in order to calculate this B1 and B2, you have to use this formula. So this formula is little bit complex. Okay, we says that summation of, if you go for B1, it is summation of x2 square, summation of x1 y minus summation of x1 x2, summation of x2 y divided by summation of x1 square and summation of x2 square minus summation of x1 x2 whole square. Okay, so it is difficult to remember this formula. So because R will provide you the solution within a fraction of second, so no need to do it through hands-on. But I have given the hands-on calculation to understand in more detailed way. Okay. So what is x1 square? In this case, x1 square is nothing but whatever value you have in this particular column, it's square. So 3 square is 9, 4 square is 16, and so on. Similarly, x2 square is nothing but whatever given in this particular column. 8 square is 64, 5 square is 25, 7 square is 49. Then we calculate x1 into y. So that is nothing but 3, I can say 3 multiplied by minus 3.7, you will get the value is minus 11.1, and so on. Similarly, we calculate x2y. So x2y is nothing but 8 is multiplied with minus 3.7. So you are getting minus 29.6. Similarly, you are calculating x1, x2. So 3 and 8 is multiplied, then you are getting the value is 24. Okay. Like that, you have to calculate for all the students. Okay, because you have to solve this B1 and B2. Okay, so you have to calculate x1, x2, all the value. But you are seeing that in this case, I am using a small letter as well as capital letter, right? So for that, again, also I have given a set of formulas. Okay, like here you can see summation of xi square is equal to summation of capital Xi square minus summation of capital Xi whole square divided by n. Okay, if you do this one, then you will get the value of summation of xi square. Okay, so in this way you can calculate. Okay, so if you calculate B1 using the formula which I showed you, the B1 value is calculated here as 2.28. Okay, and B2 value is calculated as minus 1.67. And once you determine this B1 and B2 value, you can calculate Y average. So this is Y value, sum of Y, and its average. And we can calculate x1 average, sum of all x values, that is 20, and divide by 5, that will give you x1 bar. x2 bar also we can calculate, sum of all values is 24 divided by 5. So if I put in this equation, I'll get the value of B0. So B0 value will get is 2.796. Okay, this calculation is takes so much time, so I'm not going to tell you in detail, but you refer the slide. But now I'll show you how to implement in it using R. Okay, so for this, let us go back to R. Okay, so I am creating a R script file, a new R script file. So let me rename this file by the name, let's say multiple underscore regression. Okay, so I have to take these data points which is given here. So how to take data points? What code I should write for x1, x2, and y? Because you have 3 variables. Can anybody write in the chat box and say? What is the code we have to write in R? So I can write like x1 is equal to C of these 5 values, whatever you are seeing here. What are the values? 3, 4, 5, 6, and 2. So this column is now over. X1 is over. Let us take x2. X2 is equal to C of 8, 5, 7, 3, 1. That is also over. Now I have to also show y value. Y is equal to C of minus 3.7, 3.5, 2.5, 11.5, and 5.7. Okay. So now I have entered all the values whichever given in the slide. Okay. So you know, in linear regression, I told you there is a function called linear model that is used for linear regression. And that function only we are using for multiple regression. So I can write lm and I can write y is a function of x1 and x2. Okay, x1 and x2. So it is represented as y is a tilde character x1 plus x2. And let me put this in another variable, let it be relation. Okay, relation is equal to lm y tilde character x1 plus x2. Okay, then in order to print the relation, you can write print relation. And note that this is additive. X1 and x2 is we are adding, and y is a function of f of x1 and x2. Okay, that's why we're writing this one. Some case we model it by x1 star x2. Okay, that is called as multiplicative. But here I am taking additive. So if you execute this code, x1 is taken now, x2 is taken now, y is taken now, relation is created. Now print relation, you can see whatever value I have showed you here. Okay, you have seen B0 value you are getting 2.796. So here you are getting the value is 2.8. Okay, you will get a slight difference because it is a hands-on calculation. And B1 value you got 2.28 and minus 1.67. So here you are getting 2.21 minus 1.672. See how easy to write the code in R for regression perspective. Similarly, those people who are compatible in Python, you can also write the code in Python. Okay, equivalent functions you can write. No need to write the whole scratch code, I can say, from the base level. You can use the function and do it. But it is more comfortable to use in R, and I am using R. That's why I have shown you the representation using R. Okay. And if you want to know the more about relation, what you will write? Summary of relation, and you have to print the summary of relation, right? So I'm writing print summary of relation. Okay, print summary of relation. So it will give you more details. And what is the degree of freedom here? Can anybody guess? What is the degree of freedom? How many candidates we have taken? 5. How many samples you have taken? Means how many variables you have taken? You have taken number of variables as 3. One is x1, x2 and y. So 5 minus 3 is the degree of freedom. And you can see all the p values you are getting, that is less than 0.05, which indicates that all these parameters are related to each other. Means there is a importance. When you are establishing a relation with multiple variables, okay, y is also dependent on x1, y is also dependent on x2. Okay, and overall the p value we are getting 5.104 e to the power minus 0.5, which is a very less value compared to 0.05. Okay, so this is the linear regression equation, sorry, multiple regression equation with the two independent variables. But we can go for any number of variables. So what I'll do here, I'll show you another example of multiple regression by taking more variables. So let me save it with another file by saying multiple regression 1.r. Okay. So in R, there is a predefined data set that is called as empty car data set. Okay. So there is a data set in R that is called as empty car data set. Okay. So that is, if you have installed R correctly, already your system is having empty car dataset. There is no need to download empty car dataset. But I want to take some parts of the empty car dataset. Okay. Some part of the means I want to take all the rows of empty car dataset. So you can see I have started a square bracket and I am putting a comma. So before comma, I am not writing anything that indicates that all rows. But column case, I am specifying I want only 4 columns. One is MPG, another is DISP. MPG stands for mileage per gallon. You know, in car, in fact, empty car dataset is having a lot of car models. Okay, and these car models are given with certain features. One of the feature is mileage per gallon. Another feature is cylinder displacement. Another feature is horsepower. Another feature is weight of the car. and some other parameters are there, but I am interested in only, let's say, these 4 parameters. So I want all rows, that's why I put a blank. Okay, and all these columns, specifically these columns. And what is our goal? The goal of our model is to establish the relationship between MPG as a response variable. Response variable means dependent variable, and DISP, HP, and WT as a predator variables, or we can say independent variables. Okay, and let us save this with a name. Let it be input. Okay, I missed time. Okay. So if you execute it, you can see there is an input. If you open input, so it is showing a table. These are the car name. All of you know about some of the car names, right? So it is showing you 32 different cars name. Okay, with their miles per gallon, displacement, okay, cylinder displacement, horsepower, and weight of the car. Okay. And what I told you MPG I want to take in order to establish the relationship. MPG is considered as a response variable. DISP, HV, and WT is considered as a predator variable. Okay. So now what we will do? Now we are going to apply multiple regression. Okay. So in order to apply multiple regression, before that, if you don't want to see whole data set, because this is a data set with 32 observations. But normally, whenever we do these observations, we have more number of observations. Sometimes we have billions of observations. So for that, if you want only a small set of observations to see what kind of data you have, you can simply write print head input. So it is going to show you the first 6 rows. It is showing you the first 6 rows of your empty car dataset with miles per gallon, displacement, HP, and weight. Okay. Now what we'll do? Now we'll go for the relationship. We have to establish the multiple regression relationship, right? So I can write LM MPG is a function of DISP plus HP plus WT. Okay, MPG is a function of DISP, HP plus WT, and data you have to take from input. Data you have to take from input. And let us store it with a variable called model. Okay. Then I want to print the model. Okay. So here I establish the relationship. MPG is a function of DASB, HP plus WT, and I want to print my model. So I got the coefficient value of WT, coefficient value of HP, coefficient value of DISP, and the intercept value. Those who are working, are you getting this thing? Okay, let me set the code so that you can directly paste it. Are you getting this empty car data set without explicitly installing it? Is empty car data set is available in your computer? Check once. Those who are trying, can you please respond? Yeah. Thank you. Now what I can do, we have to show the summary, right? Summary of print model. Sorry, summary of the model I have to print, right? So I have to write print summary model. Okay, it will give me more details, right? So if I execute it, I am getting more details. So let us understand what is the importance in this summary. So you know about residuals. So as you have 32 observations, it is showing in the form of 5-number summary. Minimum, first quartile, median, third quartile, median is second quartile, third quartile, and maximum. And you are establishing relationship between, not between MPG and DISP, not between MPG and HP, not between MPG and WT. You are establishing the relation between MPG against all of these at a time. We are not doing individual one. So what it is showing? So when you compare with DISP, you are getting blank. What this blank indicates? Blank indicates that the significance of this blank code is that the p-value which you got, that is 0.92851, it is in between 0.1 and 1. Here you are getting stars. What star indicates? The value is in between 0.1 and 0.5. You see the value 0.019097 is in between 0.01 and 0.05. Okay. Similarly, if you come you will look into WT, it is 2 star. 2 star indicates 0.001 and 0.01. Right? So, but what is the acceptance level? The acceptance level is the value should be below 0.05. But which case you are not getting below 0.05? Can anybody write in the chat box or respond? Which value we are not getting below 0.05? In the case of DISP, right? DISP case we are getting the value which is more than 0.05. What is our conclusion? Our conclusion is that DISP is not impacting when we consider a car model or when we consider MPG for a particular car model. Okay. DSP is not impacting, but HP also we are not getting 0.05. It is in between 0.01 and 0.1. Yes, it is. Yeah, it is also below 0.05. That means HP and WT is impacting, but other values are not impacting. Is it okay? Is it clear? So only two variables are impacting. Another variable when we take in combinedly, that is not that much impacting. Okay. And if you calculate the degree of freedom, what is the degree of freedom here? How many observations we have taken? We have taken 32 observations. How many variables we have taken here? We have taken 4 variables. One is MPG, DISP, SP, and WT, in which MPG is our dependent variable and other variables are independent variables. So it is 32 minus 4. So we are getting 28 is the degree of freedom. And overall, if you look, this is an individual one we are looking, right? But if you see overall, the p-value is 8.65 e to the power minus 11. What it indicates? It indicates that 8.65 e to the power minus 11 indicates that this relationship is justified. Means you can take MPG is a function of DISP, HP, and WT. But if p value is greater than 0.05, there is no significance in this relationship. Okay. So this is all about the multiple regression. Now we'll proceed for the third type of regression. So there is another popular regression, as I mentioned earlier, that is called as logistic regression. So there is some issue with linear regression or multiple regression. That's why people are heading towards logistic regression. So the problem with linear regression is that, like here you can see, I'm showing you two graphs. One is for linear regression and another is for logistic regression. So if you look into our response variable is having two possible values. Either the value is 0 or the value is 1. Okay. If it is a binary system, you know all the values are in between 0 to 1. And if you take a, let's say, probability score, so probability score is always in between 0 to 1, right? But when you go for linear regression, the resulting model may not restrict the predicted y value within 0 and 1. So linear model is not going to restrict it in the range of 0 to 1. Sometimes your value may exceed in this particular range. Like I told you, if the value is exceeding a particular range, then it may lead to extrapolation or unreasonable estimates, right or not? So in the similar case, here, this model is not restricting in the range of 0 to 1. But when you go for logistic regression, the predicted value y is lies between 0 and 1 range. So we get probability score that reflects the probability of occurrence of the event. But linear regression case, we are exceeding this particular limit. So that is the reason why we are having a limitation in the linear regression. And another difference, set of difference you can find in this table, in which you can see mostly we deal with the numeric data. Whatever we have seen till now, all the data are numeric data. But numeric data means, for example, marks of a student, miles per gallon, right? These are what? Numeric data. But logistic regression deals with categorical data. The meaning of categorical data is that whether a particular person is male or female. So it is a logistic regression, means categorical data. So categorical data is supported by logistic regression. And moreover, we have seen that in linear regression case, we draw a line. Okay, we draw a straight line. But in logistic regression case, it is a S-type curve. Okay. And the relationship, if you look into the dependent variable and independent variable, so linear regression requires a relationship between these two variables. But logistic regression does not require a relationship between the dependent variable and independent variable. And linear regression is used to estimate the dependent variable in case of change in independent variable. If you change independent variable, definitely the equation, if you put the changed value into the equation, linear regression equation, then you will get a different value. But logistic regression is used to calculate probability of an event. It is not like our linear regression. Similarly, coming to the distribution, residuals are assumed to be normally distributed. We have seen also different residuals we have calculated. And if you calculate the sum of the residuals is equal to 0. Right? After calculating the residuals of all the students, okay, or all the candidates which you have seen, that if you sum all the residuals, it is equal to 0. But in the case of logistic regression, residual need not be independent, but not normally distributed. Residual need to be independent. Okay, it is independent, but it is not normally distributed. As it is not normally distributed, sum is not equal to 0. And that's why most of the industrial application or many real application, you can see people are using logistic regression. Okay, coming to logistic regression model. Okay, so it is nothing but y is equal to 1 divided by 1 plus e to the power minus b0 plus b1 x1 plus b2 x2 plus b3 x3 and so on. So if you look into e to the power something, right? So that we have seen in the multiple regression case, we have written y is equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 up to bn xn, right? But in this case, what we are doing? 1 divided by 1 plus e to the power minus, and rest thing is your multiple regression. So y is called as your response variable, x is called as your predictor variables, and B0, B1, B2 up to Bn, they are considered as the coefficient. Okay, now coming to logistic regression implementation using R, it is very easy. So in order to implement logistic regression, instead of using LM function, you are going to use GLM function. Again, GLM function takes various parameters, but we are interested in very few parameters. One is formula. Formula, you know, we have already seen y is a function of x, okay, or y is a function of x1, x2, x3, x1 plus x2 plus x3, and data which you want to supply, like empty car case, we have supplied the empty cars data, and family case, you have to write binomial. So family is our object to specify the details of the model, and its value is binomial for logistic regression. So when you implement the logistic regression, you have to write family is equal to binomial. Okay. So let us implement the logistic regression using R so that you have a little bit idea about this regression technique. So let me go back to R. So let me create a new script and I'll save this script as logistic RAG regression. Okay. So let me take empty car data set only. But I told you, linear regression case, you are taking numerical data, but here you have to take categorical data. Okay. So I am taking empty cars data set. I want to take all rows, but I want to select some columns, like AM stands for automatic and manual, because you know transmission mode of a car is either automatic or manual. And we have already discussed about CYL, and we have HP, horsepower, we have WT, that is the weight of the car. Okay, I'm taking, let's say, these four. So if you want to see the first few rows of the data set, if I consider this is input, so I can write print add input. So you can see these are the six different cars. These are the six different cars. So which one is categorical? Which variable is categorical? Can anybody say? Like male, female is categorical, right? So obviously AM is a categorical variable which is either 0 or 1. CYL is either 4 or 6 or 8. It is also one type of categorical variable. But HP and WT, they are numerical variables. Right? So empty car dataset is an inbuilt dataset, nothing to download. Right? So here we have taken only 4 variables. 3 are independent variables, 1 is dependent variable. Okay, now what I'll do, I'll use the GLM function. As I said, let's say I'm writing relation is equal to GLM function. I told you GLM function takes 3 parameters. First one is formula. Formula is equal to automatic manual is a function of CYL plus HP plus WT. Data is equal to input. Family is equal to binomial. Okay. Then if I print the relation, you will get this is the result. Okay. The WT coefficient is minus 9.14947 and HP coefficient is 0.03259. CYL coefficient is 0.474860. and intercept is 19.70288. So here you are getting degree of freedom is 31. The region you are getting two different type of degree of freedom, because total observations in MTCAT dataset is 32. Okay, we have total number of observation is 32. So 32 minus 1 is 1 degree of freedom. Okay, I think I am audible. Am I audible? Yes.
Yes, sir. Yes, sir.
Okay. So degree of freedom we have calculated here is 31, because the number of observation is 32 minus 1. Another one is called as degree of freedom by considering null deviance. Okay, there is two type of deviance we are getting here. One is null, another is residual. So if you consider residual case, okay, so it is 28. Null case it is 31. We are not considering how many samples we have. Okay, but how many samples we have we are not considering. Simply we deduct by minus 1. But in this case we are considering how many? Total number of variables is 4, right? So 32 minus 4, we are getting 28. So our residual is 28. Okay, so if you want to print the summary of the relation, so you can write print summary relation. Okay, so you can see here you are getting that CYL case you are getting blank, indicates that the p value is greater than 0.05. Okay, and in the case of HP, it is dot. Dot indicates that the value is greater than 0.05 but less than 0.1. And WT case, it is star, indicates that the value is in between 0.01 and 0.05. Okay. So you can conclude that, right? You can, by looking into this, you can say that WT is impacting more, right? If I go back to my slide. Okay, this is you are getting, right? So the conclusion you can make here that is the p-value of the which you have seen in the last column is more in the case of CYL and HP, right? We consider them insignificant in contributing the value of AM, but that means the relationship is insignificant. But when you consider the weight with AM, it is impacting in comparison to CYL and HP, because that value is below 0.05. Right. Another thing you are getting here, that is number of fishermen scoring iteration. You are getting 8. So that means it require 8 number of iterations to fit this particular model. Okay. So if the value is greater than 0.05, like in these two cases, we are not considering that. Only WT is impacting the AM. So these two are insignificant. Okay. So you may consider, let's say, 100 of attributes, and you can find what are the attributes that are influencing to your decision. Okay, that way you can calculate here. Okay, the last type of regression that we are going to discuss, that is called as Poisson regression. So you can say it is more or less its implementation is same as our logistic regression. Only in the family part you have to write Poisson in place of binomial. And the difference between this regression with other regression is that it consider the response variable in the form of counts and not fractional numbers. Counts means, for example, I can say how many births happen in India today, number of births in our country. So it is a number. It is never be a fractional number. How many wins in a IPL matches? Okay, if the match is not drawn, right? Not draw, right? Then I can consider number of wins in a football match or cricket match or hockey match, whatever match you like. So it is a number. And the formula for it is log y is equal to a plus b1 x1 plus b2 x2 up to bn xn. What we are doing, instead of saying y is equal to a plus b1 x1 plus b2 x2 plus bn xn, it is log of y. Obviously, y is my response variable and x1, x2, xn is my predictor variables, and a, b1, b2, bn, they are coefficients. Okay, and you can see here, if you look into different type of variable, so by looking into this variable, you can decide which regression we can use, right? So variables are divided into categorical variable and numerical variable, right? In categorical variable, we have seen in the previous one, male, female, okay, is categorical, and we have also can make that if there is a 3-4 levels also, right? Like nationality can also be considered as a categorical variable. And on the other hand, you have numerical variable. Okay, some of the examples also I mentioned here, like marital status, political party, eye color. These are categorical variables. But another part, you have numerical variables. Okay, you have numerical variables. So numerical variable is again further classified into discrete variable and continuous variable, like number of children's, defects per hour. So these can be considered as discrete variable. In discrete variable case, you can go for Poisson regression, and continuous variable case, weight, or you can say marks of a student, you can go for linear and multiple regression. So we can use this particular function, GLM function, for this case also. GLM function takes 3 parameter: formula, data, and family, right? So formula, we know that is we are writing, let's say y is a y tilde character x1 plus x2, right? In that way we are representing it. And if you see for data we have to take a data set, and family in case we have to write Poisson. So let us implement this particular regression. So I am creating a new file, new R script file. Okay, I am creating a new R script file, and let me save this file as Poisson regression. Okay, so there is another well-defined data set, just I want to highlight you in R, that is called as Rubbrex data set. It is also inbuilt data set like our MTCAR data set, and this data set describes the effect of wool type. Wool type is considered in this data set as A or B, and tension, that is low, medium, high, on the number of rubbrex per loom. So if you want to look into the data set, I can show you. You can write rubbrex. Okay, rubbrex. Okay, you can see rubbrex. Then if you print head of rubbrex, if you print head of rubbrex, then you can get this is the data set. So here you can see breaks is 26, 30, 54, 25, 70, and 52. But wool is either A or B. So it is not showing the complete one. That's why you're not able to see B. And tension is low, medium, high. So if you open the data set from environment, so okay, let me save this with something. Okay. Just a minute. So I can write, let's say, input is equal to wrap break. Okay. So that data set will be there in input, and I want to print add up input. Okay, now you can see in the okay, now you can see A is there in wool, right? Similarly, if you come down, you will find B also. And if you go for tension, you will get H, M, and L, right? So now, if you want to implement this regression, what I should write? I can write GLM, right? So I can write formula is equal to breaks is a function of wool plus tension, and family is equal to Poisson, and data is equal to wrap breaks. Okay, or I can write input also, right? And let me save this as in relation, a variable, and let me print the summary of the relation. Okay, so you can see the breaks is a count. It is not a fractional number, right? But these are categorical variables, right? So if I execute it, I am going to get, this is my summary. So in which you can see it is saying that wool B is impacting the breaks. So it is 3 star means it indicates the value is in between 0 to 0.001, right? It indicates that wool B is impacting our breaks. Tension M is also impacting our breaks, and tension H is impacting the breaks. But tension L and wool A is not impacting. And you will get the number of observation is 54. So if you go for null deviance, 54 minus 1, so that is nothing but the degree of freedom. And if you go for residual deviance, number of variable is 1, 2, 3. But we have taken wool B, tension M, and tension H, right or not? So it is a 4 variable. One is breaks. In wool case, it is considering wool B, and in the case of tension, it is considering tension M and tension H. Okay, so the degree of freedom is 50. And as I said, number of fishermen scoring iteration in this case it is 4, which require 4 iterations to fit that particular model. Okay, so this way you can implement different type of regression techniques using R. So in this case, what we can conclude? We conclude that wool type B having tension type M and H have impact on the count of breaks. But other wool type, that is A, and tension type, that is L, that is not impacting because their P value is greater than 0.05. Yeah, there is a question that what is AIC? Okay, AIC is another measure. Okay, I think it is called as AIC. AIC is 495 here. AIC, I think it is a statistical measure, okay, for which it is actually, I think, estimating the quality of a particular model. Okay, there is a specific formula for it. I'll tell you this one later because I don't have much idea about this one. Just as I know that it is like we are calculating some kind of errors. So it is also estimating the prediction error. Okay, in this case, it is 493.06. Yeah, it is 493, correct. Okay, so this is all for this particular session. So in this session, what we have discussed, we have started with what is a regression, why we perform regression. And in the last lecture also, we have seen different examples falling under the regression. Then we have seen different types of regression like linear regression, multiple regression, logistic regression, Poisson regression. And linear multiple case, we have seen two different examples with hands-on calculation, as well as we have seen the implementation. And logistic Poisson regression case, we have seen the implementation. Yeah, this is the reference. You can refer if you want. Yeah, thank you everyone. So there is a question that could you please explain again Dept? Dept is used to save the files. If you go to R, you can see there is a Dept. Okay, I have closed that particular file. Dept is generally used to save the file. So when you write PNG, right? You are writing PNG, a file name, right? If I open, it will come. I think Dept we have used for visualization. Yes. Yes. This is used to create a chart file, right? So a chart file is created. And this is used to plot something in the chart file. But finally, what you need? You need to save that particular file. Okay. So Dept will help you to save that particular file. Okay, is it clear? Yeah. If you have any more question, you can ask. Iteration means, for example, in order to fit with a particular model, right? Like when you suppose when you develop a particular model, in the very first iteration, you may not get the success, right? So you have some objective, you have some goal. In order to achieve that particular goal, you have to repeatedly perform some iteration. One of the example I can tell you, if you know engineering mathematics, there is a method called as Newton-Raphson method. In Newton-Raphson method, or if you know about bisection method, in these methods we go on conducting different type of iterations, right? And once we got a value in same value in two successive iterations, if we get values in two different successive iterations, same value, then we stop. Let's say 2.01 you are getting in x iteration, and x plus 1 iteration also you are getting 2.01, then we stop. Similarly, in this case, number of Fisher scoring iteration indicates that when you evaluate a particular model, how many iterations are required to reach to a particular stopping condition. So on that context, it is written the value is 4, or the value is 8 in the previous something. Okay. In that way, we are calculating the number of iterations. But doing the step-by-step process is very difficult, right? Like you know, in linear regression, multiple regression is too complex. Although I showed you, right? But in this case, if you do manual calculation, you will get that particular details. Yeah. Any more question? Can we have recorded session? Yeah, I'll share the. I told you I'll share the session because now our academic is also going on. So so we are very busy because I have to again crop these videos and post in YouTube, right? So it will take time. So I'll give you these videos maybe in a regular interval, not day by day. How can we access the material folder? You go to WhatsApp folder in WhatsApp group. In WhatsApp group, under group name, okay, below the group name, you have a description. In that description, you can join in any date. There is no problem. There is nothing to join with early or late. Okay, WhatsApp description is available for everyone, irrespective of their joining in the group. In the description, Google Meet link is there, and material link is there, and all the videos also link I'll paste there. Okay, you go to your group, click on the group, you will see group name, and all the members you are also can see in that group, and on top of that there is a group description. You go to the group description, you will find the material link, and all these PPTs and codes are available under material folder. Okay, if you have any more question, you can ask.